Morning, dear student. In previous lecture, we will discuss the important phenomenon, that is transition in metal-metal bonded system. So we will discuss what types of what type of bonds are formed when metal-metal bonds binds together. So we already discussed a sigma bond is formed, that is a sigma bond is formed by the overlapping of dz square orbital of each metal atom. Then two pi bonds are formed by the overlapping of dyz and dzx orbital of each metal atom, and one delta bond is formed. One delta bond is formed, and the delta bond is formed, that is the two delta bond is formed by the overlapping of dxy and dx square minus y square orbital. So this is the case. This is the case first, in which the dx square minus y square orbital not involved in bonding with the ligand which is attached to the metal atom. So we will discuss the energy level diagram also, that is sigma, then 2 pi, then delta star. So this is the case first. We already discussed the case second. In case second, the dx square minus y square orbital is available for bonding with the ligand which is attached to the metal atom, and therefore only dxy orbital of each metal atom, only dxy orbital of each metal atom involved in bonding. So it will forms only one delta bond. So in this case both the orbital forms delta bond, but in the second case, that is case second, a sigma bond, this is case second, this is case first, that is sigma bond by the overlapping of dz square orbital, then pi bonds, two pi bonds by the overlapping of dyz and dzx orbital, and only one delta bond by the overlapping of dxy orbital, because the dx square minus y square orbital is involved in bonding with the ligand which is attached to the metals. So we will discuss some example regarding to these different types of metal-metal bond which is formed. So let us see some complexes. The first example we discuss, that is very familiar example of metal-metal bonded system, that is Re2Cl8 2 minus ion rhenium complex. Okay, Re2Cl8 2 minus ion. In this complex, if we consider this complex Re2Cl8 2 minus ion, so in this complex, if you consider the structure of this complex, it is observed in eclipse form. Eclipse form. It is observed in eclipse form. So it is observed or it is found in eclipse form. Therefore, in this case or in this structure or in this complex, only one delta bond is possible. So what is the meaning of this? That is, the dx square minus y square orbital of each metal atom is involved in bonding with these halogens, and therefore it is not involved in metal-metal bonding, and therefore only one delta bond is formed by the overlapping of dxy orbital. So it is in eclipse form. If you consider the structure, that is rhenium, then Cl, 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 and this Cl, and there is a bond order of this complex, that is 4 metal-metal bond between these two rhenium atoms. Between these two rhenium atoms. So it is observed in eclipse form. So this is the structure. So how it is observed in eclipse form? If you consider the structure that is eclipse form, then this is your, let us consider, this is your one rhenium metal atom, this is your second rhenium metal atom, and then the chlorine is attached, then the chlorine is attached to this metal atom. Again the second chlorine is attached. Similarly, one chlorine is here, another chlorine is attached to this. Similarly, this is chlorine and this is another chlorine. This is chlorine and this is another chlorine. So this circle indicate the rhenium atom, this small circle also indicate the rhenium atom, two rhenium atom, and each rhenium atom is attached to 4 chlorine atoms. So therefore it is observed in eclipse form. So due to the eclipse form, the dx square minus y square orbital of each metal atom is involved in bonding with the ligand which is attached to the metal, and therefore only one delta bond is formed. So if you consider this rhenium Cl 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 Cl, it is a square planar complex or a square planar geometry. If you consider only rhenium atom and the 4 chlorine attached to the rhenium atoms, okay, let us consider the half part of the complex. This is a square planar complex. We know that the square planar complex, having the hybridization, that is dsp2 or sp2d. So in this case, one d orbital, one s orbital, and two p orbital, that is px and py orbitals, are involved in bonding. So the geometry or the shape of this rhenium Cl4 is square planar. The geometry is square planar or the structure is square planar, it having hybridization dsp2. So in this case, one d orbital, one s orbital, and two px py orbitals are involved in bonding. So we know that if you consider the bonding in this Re to Re, Cl, 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 it is dsp2 hybridization. If you consider, we know that the s orbital is spherical in shape. Then if you consider, this is your px orbital, and then this is your py orbital. So one s orbital which is spherical in shape, px py which is dumbbell in shape, that is along the axis, okay. And for effective overlapping, so one s orbital, two p orbital, and one d orbital is required for dsp2 or sp2 hybridization. Therefore for effective overlapping, which d orbital is required for this hybridization, that is dsp2 hybridization? If you consider the shape of d orbital, that is, if you consider this pxy and this py, they are along the axis, so we required a d orbital which is lie along the axis. So we know that only dx square minus y square orbital and dz square orbital lie along the axis. So out of two, that is dz square and dx square minus y square orbital, anyone is involved in the bonding with this, anyone involved in the hybridization, that is dsp2 or sp2d. But we know that dz square orbital involved in bonding, that is involved in metal bonding to form a sigma bond. So it is not involved in this hybridization. So the remaining orbital, that is dx square minus y square orbital, which is similarly look like to this px py orbital, so it will involve in this hybridization, and therefore the dx square minus y square orbital not involved in metal-metal bonding, it is involved in bonding with the ligand which is attached to the metal. So if you consider the dx square minus y square orbital, that is, let us consider this is your x-axis and this is your y-axis, then this is the orbit. So this is your dx square minus y square orbit. So this dx square minus y square also have a lobe along the axis, and therefore for effective hybridization, for effective bonding, we require dx square minus y square orbital. So the orbital which is involved in bonding, that is dx square minus y square, then s orbital, then px, and then py orbital, and therefore the hybridization is dsp2. So one of the d orbital, that is dx square minus y square orbital, involved in bonding with the ligand which is attached to the metal atom, and therefore this ReCl4 having dsp2 hybridization, and it is a square planar structure, and therefore this dx square minus y square orbital not involved in bonding with metal-metal bonding system, and therefore only one delta bond is formed by the overlapping of dxy orbital. So if you consider the remaining orbital which is available to form a bonds, that is dz square orbital of each metal atom form a sigma bond, then dyz and dzx orbital involve to form 2 pi bond, and only dxy orbital is available to form one delta bond, because dx square minus y square orbital is already involved for the bonding with the ligand which is attached to the metal, and therefore in this complex it is in eclipse form, and therefore only one delta bond is formed by the overlapping of dxy orbital. One delta bond is formed. So let us consider the bond order. Or find out the bond order of this Re2Cl8 minus ion complex. If we consider this complex and find out the oxidation state of each rhenium atom, then 2x plus the chlorine having minus 1 charge, that is minus 1 into 8, which is equal to the charge, overall charge, that is minus 2. Therefore twice x plus minus 8, which is equal to minus 2. Therefore twice x, which is equal to minus 2 plus 8, so twice x, which is equal to 6, and x is equal to plus 3. So in this complex, that is rhenium halogen complex, each rhenium atom is in plus 3 oxidation state. So if you consider the plus 3 oxidation state, that is rhenium, we know that the rhenium is from the manganese family. If you consider the general configuration of this family, that is 4s1 complex, manganese, technetium, rhenium. Okay, so it is the member of manganese family. So 4s2 3d5 valence configuration, but it is present in plus 3 oxidation state. So rhenium, it is in plus 3, therefore 4s0 3d4 configuration. So each rhenium is present in plus 3 oxidation state, and it has a valence, it has a configuration, that is 4s0 3d4. So another rhenium is also having configuration 4s0 3d4. So total 8 electrons are available for bonding. So each rhenium contribute 4 electrons, another rhenium contribute 4 electrons. So total 8 electrons are available for bonding. And if you consider the bonding in this complex, that is, we know the energy level diagram. That is sigma, then 2 pi, and then one delta bond is formed. Then here delta star, here pi star, and here sigma star. So this is the molecular or energy level diagram. This is a energy level diagram for case second. So in this case, the dx square minus y square orbital not involved in the formation of delta bond. So only one delta bond is formed by the overlapping of dxy orbitals. So this is bonding molecular orbital, this is anti-bonding molecular orbital, and we know that so each rhenium contribute only 4 electron for bonding and another rhenium contribute 4 electron for bonding. So total 8 electrons. So if you consider 2, 4, 6 and 8. So all these bonding orbitals, all these orbital, lower energy orbital or HOMO, highest occupied molecular orbital having lower in energy, therefore they are filled first. And if you consider the bond order in this case, bond order which is equal to 1/2 into number of electrons in bonding molecular orbital minus number of electrons in antibonding molecular orbitals. So electrons in BMO minus electrons in ABMO, antibonding molecular orbital, and therefore 1/2. So total electron is 8 minus 0. So here we get 8 by 2. So the bond order is equal to 4. So in this complex, that is Re2Cl8 2 minus ion, this complex contain 4 metal-metal bonds, that is the bond order is equal to 4. So if you draw the structure of this complex, that is if you draw the structure of this complex, that is this rhenium 1, 2, 3, 4 bond is formed between this rhenium, and then this Cl, 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 and this. So there is a 4 metal-metal bond between these two rhenium atom. So this is the example of case second, in which dx square minus y square orbital not involved in the formation of delta bond. Instead of, it will involve in the bonding with the ligand which is attached to the metal atom. So this is the example of Re2Cl8 in which the bond order is equal to 4. If you consider another example of same category, if you consider another example, that is osmium 2 Cl8 2 minus ion. So this is another complex, that is osmium 2 Cl8 2 minus ion. In this case, if you consider the configuration of osmium, so osmium is a member of iron family, iron, ruthenium and osmium. So if you consider the valence configuration, that is 4s2 3d6. So if you find out the oxidation state, again in this case 26 plus minus 8 which is equal to minus 2. So 26 which is equal to minus 2 plus 8. So 26 which is equal to 6 and x is equal to plus 3. So each osmium is in plus 3 oxidation state, and therefore osmium, it is in plus 3, it will gives 4s0 and 3d5 configuration. So another osmium is also in osmium plus 3, it also contribute 4s0 3d5. It also have a configuration, that is 4s0 3d5. So total 10 electrons are available. Total 10 electrons are available for bonding. So if you consider 10 electrons are available in bonding, so if you consider the energy level diagram, that is OS2 Cl8 2 minus ion. So in this case total 10 electrons are available, and same is the case, that is one of the dx square minus y square orbital is involved in bonding with this chlorine atom, and it is not involved in the bonding in the formation of delta bond. That is, in this case dx square minus y square orbital not involved in delta bond formation. not involved in delta bond formation. And if you consider the energy level diagram, that is sigma 2 pi 1 delta bond by the overlapping of only dxy orbital of each metal atom. Similarly, this is your sigma 2 pi delta, then this is your delta star, then this is your pi star, and this is your sigma star. So total 10 electron is available. So first these lower energy orbitals are filled. So total 2, 4, 6, 8, and the remaining 2 electrons are goes into this delta star orbital, that is 10 electron. So total 10 electron is available for bonding. 2, 4, 6, 8 are bonding molecular orbital, while 2 electron goes into the anti-bonding molecular orbital. And if you find out the bond order, in this case bond order, which is equal to 1/2 number of electrons in bonding molecular orbital, that is 2, 4, 6 and 8, 8 minus the number of electrons in anti-bonding molecular orbital, that is 2 electrons. So total 8 minus 2, 6, 6 by 2, so we get 3. So in this case a triple bond is formed between two metal atom, that is between two osmium a triple bond is formed because the bond order is equal to 3. So in this case only one delta bond is formed because the dx square minus y square orbital is not involved in the formation of delta bond. So it is involved in bonding with the ligand which is attached to the metal. So the bond order is 3. So if you draw the structure of this osmium complex, if you draw the structure of this osmium complex, osmium, and there is a triple bond between these two osmium and this Cl, 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 here also Cl, 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 and this is Cl, and having a charge -2 charges. So this is the structure. So this OS2Cl8 is observed in staggered form. It is very important, you should keep in mind. So it is involved in staggered form, it is not involved in eclipse form. So it is involved in staggered form. So this is regarding to the OS2Cl8 examples. So both examples are of case second, in which dx square minus y square orbital is not involved in delta bond formation, it is involved in bonding with the ligand which is attached to the metal. So if you consider another example, that is if you consider the case first, or if you consider another example for homework, that is Re2 Cl4 PMe2 pH PMe2 pH4, this is first complex. Second Re2 Cl4 PMe2 pH4 having plus charge, and third, that is Re2 Cl4 PMe2 pH4 having +2 charge. So you find out the orbital which is involved in the bonding, so how much metal bond in each complex. So you should find out the bond order for these complexes. In next lecture we will discuss the remaining points or remaining example regarding to the metal bonded system. So this is all about the transition or the system involving a metal bond, but in this case the dx square minus y square orbital is not involved in bonding to form a delta bond, therefore only one delta bond is formed. So the classical example is the rhenium Re2Cl8 2 minus ion, then osmium 2 Cl8 2 minus ion. These are the examples. For this example you have to find out the bond order. So in this case also the dx square minus y square orbital is not involved in bonding not involved in delta bond formation. It is involved in bonding with the ligand which is attached to the metals. So for these complexes you have to find out the bond order. In next lecture we will discuss the remaining point regarding to the photochemical reaction. Thank you.